Earth Systems 3209. Unit 4, The Forces Within Earth. References for this unit can be found in Chapters 4, 15, 16, and 19, and also can be found in Appendix A and B of the Curriculum Guide. Unit 4, Topic 4.2. This topic looks at the causes and locations of earthquakes. We will focus on describing the causes of an earthquake, discussing the relationship between earthquakes and the elastic rebound theory, and focuses on identifying the environments where earthquakes occur and relating them to locations along plate boundaries. When we look at the cause of earthquakes, we must answer the question, what is an earthquake? An earthquake is the vibration of Earth produced by a sudden rapid release of energy. And earthquakes are studied in the branch of earth science called seismology. When an earthquake occurs, the elastic energy is released and sends out vibrations that travel throughout the Earth. These vibrations are called seismic waves, and the study of how seismic waves behave within Earth is called seismology. References for these topics can be found in the text on pages 441 to 443. To understand earthquakes, we must first look at where the earthquake will occur. So for this, we turn to locating the earthquake focus and the earthquake epicenter. The focus of an earthquake is the exact location within Earth where seismic waves originate and are generated by a sudden release of stored elastic energy, most often located on a pre-existing fault. The position directly above the focus on the Earth's surface is what we refer to as an epicenter. If we look at the diagram below, we will see that an earthquake is located on a fault plane, and the focus of this earthquake is where the energy originates. Directly above the focus on the Earth's surface would be the position called the epicenter. What causes earthquakes? Earthquakes occur when energy stored in elastically strained rocks is suddenly released. And this release of energy causes intense ground shaking in the area near the source of the earthquake, which we refer to as the focus. And this energy sends waves of elastic energy, called seismic waves, outward in all directions throughout the Earth. Earthquakes can be generated by bomb blast, volcanic activity, and also sudden slippage along faults. Earthquakes are definitely a geologic hazard for people that are living in the earthquake regions, but the seismic waves generated by earthquakes are invaluable for the study of the interior of the Earth. And these earthquake waves reveal a lot about the interior of the Earth. When we look at the cause of an earthquake, we must first look at how does earthquakes originate. Earthquakes originate when we have movement in areas along a fault plane, and this movement stops. When the movement along a fault plane stops, the fault is said to be stuck. Elastic energy is stored in the rock as the rock becomes deformed and bends, much like that in a bend stick. When the elastic strain build-up along the fault exceeds the elastic limit and the rock cannot hold the strain anymore, the rock will break or slip at its weakest point. And this weakest point is what we call the focus. And this is where the energy originates. The slippage along the fault allows the rock to snap back, and the vibrations sends out waves of energy in all directions, called seismic waves or earthquake waves. And these earthquake waves move throughout the rock in different phases. The first wave of energy is called the primary wave, the second wave, secondary wave, and the final wave travels along the surface and are called surface waves. Once the energy is released, the Earth springs back, and this springing back of Earth is called elastic rebound. When we look at the studying of earthquake waves and seismology, elastic rebound theory explains the reasoning behind earthquakes. The mechanism that causes earthquakes was not understood until H.F. Reed proposed his idea of elastic rebound. Reed suggested that most natural earthquakes are caused by sudden slippage along a fault zone. If we look at the diagrams below, we notice that the original position of rocks before any strain. We can look at an indicator, such as the black line, that travels through an area of rock. And here, the black area travels perfectly horizontal. But once you put strain on the rock, this black area will tend to deform in the directions of the strain. The elastic rebound theory, suggested by H.F. Reed, suggests that if movement along the fault sticks, elastic strain energy builds up, deforming the rocks on either side of the fault. So in the diagram to the right, we notice that a feature across the fault bends as the rocks on both sides of the fault pushes in opposite directions, and elastic strain is building up along the fault. So the stresses that we see here are called transform stresses, or shear stresses, which form along the transform fault. When the rocks along the fault can no longer hold the strain, slippage occurs at the weakest point along the fault, and this is called the focus, which causes rocks to start moving on both sides of the fault. Energy is released in all directions, which we call an earthquake. So if we refer to the diagram below, we see the fault rupturing and the elastic energy being released in all directions. When the elastic strain is released, the rocks on both sides of the fault will snap back to their unstrained positions. In the diagram now, we see that the stress is released from the rocks, and the rock on both sides of the fault plane would snap back to nearly horizontal positions. Let's look at the location of earthquakes on the global scale. Around the Earth, we have several earthquake belts, but about 95% of all energy released by earthquakes originate in only a few narrow zones that wind across the globe. The greatest concentration of earthquakes are located along the outer edge of the Pacific Ocean, in an area known as the Pacific Ring of Fire. So if we look at the diagram here to the right, we see the dark concentration of dots actually border the whole Pacific Ocean. And as we move up around the Pacific Ocean, this is referred to as the Pacific Ring of Fire. And all of the concentration of earthquakes are located surrounding the Pacific Plate along the edges of different plate boundaries. If we look at the location of different earthquakes, location of earthquakes are determined by the earthquake depth. Seismic records show that earthquakes originate at depths ranging from 5 kilometers to 700 kilometers in depth, and can be classified according to the depth of occurrence. Even though earthquakes range at different depths from 5 to 700 kilometers, approximately 90% of all earthquakes will occur at depths less than 100 kilometers. And the depths of earthquakes are classified as follows. Shallow focus earthquakes usually occur at depths less than 70 kilometers. Intermediate earthquakes occur at depths between 70 and 300 kilometers. And deep focus earthquakes occur at depths greater than 300 kilometers. You can see references in the textbook on page 447 to 451 regarding locating earthquakes and the depth of earthquakes. When you look at earthquake depths, all earthquakes can occur at any of 3 different tectonic plate boundaries. Let's first look at divergent plate boundaries. At a divergent plate boundary, earthquakes are generated along the ocean ridge system, always have a shallow focus and are not very strong. Some examples of where earthquakes could be generated along divergent plate boundaries will be along the Mid-Atlantic Ridge. In the diagram to the right, we see an oceanic ridge where the plates are moving apart due to tensional forces, and tensional forces do not build up a lot of strain. Therefore, the movement of the plates along these boundaries tend to be or produce very weak earthquakes, and mostly these earthquakes are primarily due to movement of magma along the boundaries. When we look at transform fault boundaries, in a transform plate boundary, earthquakes generated along this type of boundary have shallow and very powerful earthquakes. Examples of earthquakes that occur along transform plate boundaries are seen in California along the San Andreas Fault. If we look at the diagram to the right, we see a transform fault boundary where shearing forces cause the plate to move in opposite directions. Along the transform fault, we see the plate getting stuck, strain building up, and then sudden slippage. The sudden slippage can move the tectonic plates up to several meters where the energy is released, and the resulting earthquakes are generally powerful earthquakes ranging anywhere from 5 to 9 on Richter magnitude scale. Finally, at convergent plate boundaries, we see earthquakes generated along convergent plate boundaries. They range in depth and are very powerful. The focus of an earthquake along convergent plate boundary, the depth can increase with the distance away from the trench, ranging from shallow to very deep focus earthquakes. This earthquake zone is called the Wadidi-Benioff zone. An example where earthquakes of this magnitude and type can be found along the Japan Trench off the coast of Asia. If you look at the diagram to the right, we notice that we have green arrows that indicate shallow focus earthquakes. We have yellow dots that indicate intermediate focus earthquakes, and then we see the red dots which indicate deep focus earthquakes. And again, as we go from shallow focus earthquakes to deep focus earthquakes, we move farther away from where the subduction originates, called the trench. So very near the trench, we see primarily shallow focus earthquakes, and the farther we move away from a trench along the Earth's surface for the epicenters, they would be above deep focus earthquakes. Let's look at some examples. Example number 1 reads, the most common cause of earthquake is. Our choices: collapse of limestone caverns on the borders of continents. Choice B, the increasing stress between tectonic plates. Choice C, energy released by volcanic eruptions. And choice D, the gravitational pull of the moon and sun on the continental landmasses. Of the two choices, we notice that B will be the most common cause of earthquakes. Energy released by volcanic eruptions can or may cause a very shallow and a very mild earthquake, but the most common cause of earthquakes will be B, the increasing stress between tectonic plates. And when this strain is released, it can cause very large earthquakes, such as those associated with transform plate boundaries and convergent plate boundaries. Let's look at example number 2. Example number 2 reads, at which of the following locations would you least likely find earthquakes? Earthquakes are located, and very strong earthquakes are associated with transform fault boundaries. Very strong earthquakes are associated with subduction zone boundaries. And nuclear testing sites would emit a lot of energy, so therefore you would see very powerful earthquakes at a testing site for nuclear. Where we see very mild earthquakes, if any earthquakes, will be associated with divergent boundaries. So the answer to this question, which location would you least likely find earthquakes? The answer would be B, divergent boundaries. Your turn. Take the time now and complete the following question. You can pause your recording to prepare your answer, and the solution will follow. The question reads, earthquakes commonly occur at plate boundaries. With reference to elastic rebound, what causes an earthquake? So if we look at elastic rebound, the answer to this question will be as follows. There is a buildup of stress or energy within tectonic plates where it reaches the elastic limit. The plates then rupture or snap, and the stored energy is released. Plates then move back to the unstressed positions, releasing the stored energy as seismic waves. And this releasing of stored energy is what we call an earthquake. Thus, if you look at the answer and refer back to the elastic rebound theory, the elastic rebound is the rebounding of the rock once the elastic strain is released. And this elastic strain is generally built up along a fault until it reaches its elastic limit, and then it will release the energy and the plate snap back, causing an earthquake. So that would be the answer to the above question. Let's have a look at the points covered in this presentation. Some of the overview of the points covered. It states that elastic rebound can explain the cause of earthquakes, and the elastic rebound theory was proposed by H.F. Reed. Earthquakes are limited to narrow areas around the globe, and these narrow earthquake zones predominantly occur around the Pacific Ocean, and they focus about 90% of all of the earthquakes worldwide. Earthquakes exist at all plate boundaries, even though at divergent plate boundaries the earthquakes that exist are shallow focus and very weak in comparison to earthquakes that originate at transform boundaries and subduction zones. These earthquakes are relatively strong earthquakes. And earthquake depths vary from shallow to intermediate to deep along subduction zone boundaries. If you travel farther away from the trench at a subduction zone boundary, we will progressively go from shallow focus earthquake to intermediate focus earthquakes to deep focus earthquakes. And this is represented by the Wadidi-Benyat zones that are associated with subduction zones. So these are the main points covered in this presentation.